Good morning, everyone, and welcome to this edition of Curiosity Uncovered. So today we'll be discussing how we see our universe in a different light. So what do I mean by this? So imagine looking up at the night sky and seeing only the twinkling stars against the darkness. Now imagine if you could see beyond the visible light. So that'd be this spectrum right here. So you could see infrared, ultraviolet, or even X-rays. And the universe would look completely different. That's exactly what NASA scientists do. They use telescopes, which is this thing right here, and other special instruments to capture and filter different energies of light, revealing details we could never see with our eyes alone. So why is this important? So objects in space radiate energy across the full electromagnetic spectrum. So some emit visible light, like our sun, but many others shine in different wavelengths we cannot see, like radio waves, microwaves, or even gamma rays. And by using different tools like telescopes and spectrometers, scientists can filter and analyze these energies, uncovering incredible details about our planets, stars, galaxies, and even black holes. So now let's connect this idea to something more familiar, our colors and filters. So what we're going to do is we're going to do a little activity. So if you want to do this activity home, there's two different ways you can do this. So the first two things we need are some black and white paper. I have a blue and pink highlighter. And then I also have a blue and red colored pencil. So what we're going to do is, here, let me move this out of the way. Well, on our white paper, we're going to use our blue and pink highlighters to draw something. I'm going to do that real quick. All right. Now, I just wrote "stay curious" on my white paper. Now I'm going to do the same thing on my black paper with my colored pencils. Then, what we're going to do is we're going to look through this through these two filters. So we have a red light filter, which is a red cellophane, or we have our blue light filter, which is going to be our blue cellophane. So now we're going to look at this "stay curious" I just drew on our white paper through our red filtered light. All right, now we're going to look at our blue filtered light. All right, now hold on what you thought. Now we're going to look at our black paper now. So we're going to do the same thing, look at through our red. Now our blue. What do you guys notice? Was there a difference? Let's talk about it. So we just saw in our activity how color filters change the ways the colors appear on our white versus black paper. So when you held up the red filter to our white paper, you only saw the red light passing through. Why? And that's because the white paper, the pink, is just a lighter shade of the red, and it blended in with the red light coming through the filter. When we looked at the red on the black paper, it stood out even more because the black paper absorbed all the other colors, letting the red be more visible. Now, this same concept is used in telescopes. So, scientists place specialized filters on our telescopes to isolate specific wavelengths of light. So, some filters block out bright background light, allowing astronomers to see first objects like distant galaxies or exoplanets, and others are designed to highlight certain elements in space. So, for example, hydrogen is the most abundant element in the universe. It glows in a specific shade of red called H-alpha. By using a H-alpha filter, scientists can bring out hidden structures in nebula where new stars are forming. So we're going to look at that. So what we're going to do is we're going to look at how different telescopes are also designed to detect different types of light. So what we're going to look at is some images that were captured by the Hubble Space Telescope. So different telescopes are also designed to detect different types of light. So the Hubble Space Telescope captures images in visible and ultraviolet light using these filters to separate the different colors and create stunning composite images. So the James Webb Telescope, though, specializes in infrared light, allowing it to see through cosmic dust to observe forming planets and galaxies. Meanwhile, our Chandra X-ray Observatory detects high-energy X-rays emitted from black holes and supernovas, which would be invisible to optical telescopes. Each of these telescopes is like a set of different filters. It helps us uncover the different layers of our universe. And that's what we're going to look at right now. So what we're going to do is we're going to pop up an image real quick, and we're going to use those same filters again. So the first image we're going to see is of NGC 604. This is one of the galaxies we have out there. So we're first going to look at it through our blue filter light. All right, now we're going to look at it through our red filter light. Do you guys notice the difference? Now we're going to do the same thing with our next one, and it's our Phoenix Galaxy Cluster. So we're going to do our red first, and now our blue. You guys see the differences? This is what these amazing telescopes do. And that is why they are extremely important. And then our last one is our NGC 2818. Our red we're going to look at, now our blue. I find this quite shocking and quite amazing how these images look so different through these different filters. Why does this matter? So filtering light helps scientists decode our universe. So what it's made of, how it's changing, and even how it began. So without these tools, we'd be missing out on our full picture like you guys just saw with the different colors. And these colors made it seem simpler or more advanced. And now NASA's advanced filters and telescopes change how we see our cosmos, revealing hidden details and even expanding us on our understanding of our universe. The next time you look out at the night sky, think about all the unseen light that's out there. Science is always finding a way to see beyond the visible. And who knows, maybe one day you'll be discovering something hidden in our universe. So thank you guys for coming out and learning with me today, and I'll see you next time.